All right, so we're starting off Unit 6. I'm going to skip all of this vocabulary, and I'm going to the start of Lesson 1. Okay, Lesson 1 is all about roller coaster design. We're going to skip a lot of this part, and we're just going to talk about things being continuous, because you don't want to fall off of a roller coaster. So the whole big thing that we're thinking about a roller coaster is because we're talking about the word continuous. Continuous means that it does not lift up, like you're not going to fall off the roller coaster. Whereas something like this, you definitely would. Okay, you really shouldn't have something where you jump and there's no track. Okay, so when I look right here, roller coasters are just one of the many applications for polynomial functions. When we're looking at this, I see it start up here, and this is a maximum. I see it come down to here, and this is a minimum. I see it come to here. That's where it ends, and I see it kind of go up and back down, so this makes a maximum as well. We're going to talk about some vocabulary here. We're going to talk about the words relative, maximum. That means that it is a maximum, but it's not the very most maximum. This one's your absolute maximum for what we can see. Okay? This would make an absolute minimum because it's the lowest we can see. Okay, so still going. I'm going to skip a lot of these things. So we're talking about things that are smooth and continuous. So another thing you don't really want on a roller coaster is something that's pointy. So even though this is continuous, because it's pointy, it's not smooth. So we're going to say this one's not an option because it is not smooth. Okay, so that's not going to work for our roller coaster because it is not smooth. Okay. This one does work for my roller coaster. It is smooth. It is continuous. Okay. This one does not work for my roller coaster. It is not smooth. This one does work for my roller coaster. This one does not work for my roller coaster. It has a gap. It is not continuous. Okay. D does not work for my roller coaster. It has a gap. It is not continuous. Okay. We're going to talk about a bunch of vocabulary having to do with these. So we just talked about smooth. We just talked about continuous. I just used the word gap. Okay. Anytime I have these points, that creates a point of inflection. Okay. Anytime that it changes direction, that's a point of inflection. We're going to talk about x-intercepts, maxes, mins, relatives. We're going to throw some bunch of vocabulary at you today. So I've got some things that are polynomial functions and that aren't polynomial functions. Today we're not going to deal with that. We're going to come back to that later. But I'm looking for the, what a polynomial really is. And so we've dealt with lines, which is like that y equals mx plus b. So I could have something like 1x plus 2. That's a polynomial. It has more than one term. Okay. I've got like the regular number 1. That's a monomial. There's only one term. It's technically not a polynomial. Then I have something like 2x squared plus 3x minus 1. That's a quadratic. It's a polynomial. Okay, and we go on and on and on. So we can get things that are called cubics, and then we keep going and going and going. So we're going to talk about the shape of some of these. We know that this one is a line. We know that this one is U-shaped. And then we're going to start to learn about how this one looks like the little dancies. Okay, so it does a little dancey dance like arms. We do need to understand that a standard form of a polynomial is written with the highest exponent first. So you can see that 2 got written first, the 3 would be written first. If I had like x to the 5th plus 7x to the 7th, that would be incorrect. We would have to switch these. That 7x to the 7th would have to go in front. Okay, it needs to go in order of highest first. So then we write the terms with the lower exponents in highest to lowest order. A constant term always goes last. We always combine like terms. So if I had something where I had x squared plus 2x squared plus 3x, you know to combine those and rewrite them as 2x squared plus 3x. Okay, so that's kind of like the background behind polynomials. We've done a lot with these. A lot of this vocabulary is familiar, and it's just getting to the point where we're talking about like things all combined together. So we need to remember these like different things. A coefficient, I know that that was one on the PSAT that threw you for a loop. A coefficient is just a number in front of a variable. So for example, in 7x to the 7th, this 7 is my coefficient. Okay, we have special names for the 3. It's a cubic. We have special names for the quadratic. For the 2, it's a quadratic. We have special names for just the x. It's a linear. And then just a constant is the very last thing. It is just a number. Okay, so you don't need highlighters, but we're going to talk about a couple of things here. We're going to talk about this point and that point. Both of those points are maximums. Now, in elementary school, you might have only learned about this maximum, and this is what we called an absolute maximum. We need to start adding that word to it because it tells us that that's the very tippy top. This maximum, however, is also called a relative maximum. It is a maximum because something goes up and then it comes down. So it's a maximum compared to a lot of other things. It's like the top of a hill. So we're looking for anything that's the top of a hill. In the same respect, our valleys are called minimums. Our valleys are called minimums. And we have to check our endpoints. So right here, it's kind of hard to tell if that's a maximum or a minimum, but usually we can see like if it's a max or a minimum. So this one's coming from a down to an up. It's going to be a minimum. Okay, we would then call this one relative. The reason this one is relative is because that one's just a little bit lower. Okay, they're going to refer to these as turning points. We're going to talk about turning points in a bunch of different ways. So turning points will be mins or maxes. Turning points will be called points of inflection. See, I skipped all that vocabulary, but it was kind of a lie. I'm just doing the vocabulary within it. And then they'll also be called critical points. Points that are important, critical points. So how many turning points are shown on there? I've got this one where it turns, this one where it turns, that one where it turns, and that is 3 points. There are 3 turning points. Notice I didn't count the last one. The last one hasn't quite turned all the way yet, so we're not going to talk about that one. Okay, we've already talked about this relative minimum and maximum. So we need to go through here and we need to point out our critical points, our turning points. So as I follow, it turns right here. As I follow, it turns right here. As I follow, it turns right here. As I follow, it doesn't turn again. There are 3 of them. It's still important that you know that as I'm going this way, I'm decreasing. As I'm going this way, I'm increasing. As I'm going this way, I'm decreasing. Right here, I'm increasing. Okay, so it's really important that we know that. So I'm going to start showing that with negative signs and positive signs. Even though this arrow goes this way, we read from left to right. This is actually increasing. I hit a critical point, a point of inflection. It's going down, so I'm decreasing. That's a negative. I hit a point of inflection. It hits a slight positive, where then I hit another point of inflection, another critical point where I turn, and now it's going down. Again, there's 3 points there. 1, 2, 3. Okay. I'm going to erase on here. I want to talk about how this and this are both maximums. This is a relative maximum because it is lower than the highest maximum. This is also, this is an absolute maximum because it is the highest that this graph goes. Something that is interesting here is that this point we would also call a relative. It's a minimum. It's the only place where I like hit a bottom and go back up, but compared to my endpoints, it is not the lowest thing. So it is not the lowest thing on my graph. I can't call it an absolute. It is a relative minimum. So right here, I'm just going to count turning points. Turn, 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 turn. 1, 2, 3, 4, 5. You are going to go label. My hint to you is that there is no absolute max, but there is an absolute minimum. Okay. So you'll do that. So go ahead, pause here, take care of that. Okay. If you're a history person and you want to read, you totally can, but we're not doing this page at all for the purposes of our class. Okay. This thing has a huge, giant fraction. Don't love it. Skipping it. Still on the same thing, huge, giant fractions. Don't love it. Skipping it. I'm here. I'm looking at this thing that's a polynomial. It's a polynomial because it's smooth and it's continuous. Okay? These 3 things that they've already labeled for you are x-intercepts. You should also talk about your points of inflection or your critical points, the places where they turn. This is a maximum, this is a maximum, this is a minimum. Now I need to talk about relative versus absolute. Okay? I also want you to understand that this is also a minimum because it's a bottom, it's a valley. This is also a minimum. It's a bottom, it's a valley. My maximums are both relative because my endpoints are going to keep going and going and going. And so neither one of these is the tallest. They're both relative. Okay? This minimum is an absolute minimum. It's an absolute minimum because it's at that very bottom place. Okay, the very, very bottom of my screen. That makes my other two minimums relative. Relative. So they're a bottom, they're a low, but they're a low for that piece of the graph. They're not the lowest that graph really goes. Okay? On not a polynomial, I get things that are called cusps. We'll talk about that way later. Okay? I get things that are called gaps. We know. We get it. And then we get a hole, which is just one point, is not continuous. Okay, there's a bunch of places here that are points of inflections that are maximums, minimums. We're not going to touch that. We're just going to keep going. So I answered the questions 15, and I did not answer question 16. So you need to go and tell me how many turning points or points of inflection are there. So homework problem set. I am not going to do any of this page. Okay, the rest of today is you just working. So it's working time. There's a couple of directions I'm going to go through. So I want you to notice that they do their box on the right-hand side instead of on the left-hand side, and they do that so that you can combine. So notice that they do on the side, on the right-hand side instead of on the left-hand side. They do that so that they can add across this way, and it works out nicely. Whatever. So x times x makes x squared. 8 times x makes 8x. X times 7 makes 7x. 7 times 8 makes 56. This made 15x. See how it nicely went across and you didn't have things in your way. This made an x squared. This makes a 56. So that's why they do it on that side. If you really want to redraw the box, you can redraw the box. So I skip this step and I go straight to here. This is x squared plus 15x plus 56. So that's your standard form. It's written like highest exponent, middle exponent, lowest one. Okay? So they want to know how you could multiply without using a table. You could double distribute. You could go do this weirdo schmeardo thing where they break it into two different problems and have you distribute that way. But we like the box. We do the box unless you are coming from honors and you like to do the double distribute instead. So then I need you to see that this is a 3 by 3. And they go and they fill in. And you can do that. And you'll get to a final answer. And then this one will make a 3 by 2 box. And you can go and fill in and get an answer. They say it's easier if you make it a 3 by 3. And you change that x squared to be a x squared plus 0x minus 2. And the reason why they like that one is because they like to be able to go across and add. It's your choice, whatever you like. Okay, so then when I have things that are side by side by side, I need to do them 2 at a time. So I take the x plus 1 times the x plus 2. The answer I get from this will be x squared plus 3x plus 2. And you need to bring that over. So you need to go show your work, bring that over, and then do another box. So then they want you to show me with a plus b times c plus d. I'm excusing you. We're not doing that. Ooh, you are missing pages that I have. Yours are in a different place than mine. So then I need you to understand that we have in behavior of a polynomial function. So my in behavior is that this one faces downwards. It's a negative. This one's a positive. We call that concave up. Or concave down. This shows that as I approach infinity, I go to negative infinity. So as I approach that way, I'm going to negative infinity. As I approach that way, I'm going to negative infinity. Same thing, but opposite. This one hits infinity going both ways. So your endpoints, the places where you end, are going to infinity. We know about zeros. We know about x-intercepts. So your zeros of this equation is -1 and +2. So my equation is going to give me x minus 2, x plus 1. Notice that those are opposites of my zeros. And then it gets a negative because that one's upside down. So you have to do B. So it's asking what's the difference between cubics and second degrees. Ideally, a quadratic goes two directions. Have one turn and a max of 2 zeros. So they go down and then up 2 directions. They have one turn, and if I place this in the right place, I would get 2 x's. But that's the most I could get. So I could get just one x-intercept, I could get 0 x-intercepts. So you need to go and make me an ideally for 3. And ideally, cubics do what? Then I need you to go and I need you to find how many zeros these ones have, how many zeros these ones have, how many zeros these ones have. On the next page, we talk about multiplicity. So multiplicity is that coming here and bouncing means that I hit that twice. It means that I hit -1 and I hit it again. So really, my graph looks like x minus 1 times x minus 1. Because those are both positive, sorry. So, we're going to skip this page for right now. This has a multiplicity, it bounces. This one has a multiplicity of 3, it goes straight through. Okay, so it curves, it goes straight through. Come in here. So, looking at my zeros. I have a 0 at 0, -3, +2, -1. All opposites of those, plus a 0 for the x that's by itself. So a 0 for the x that's by itself, but that has a twice multiplicity. So notice that multiplicity. And then a -1 becomes a +1. This means that this was an x cubed graph. This one was an x to the 4th graph. Notice this had a negative in behavior. This one had a positive in behavior. This is going to be an x to the fourth, and it's positive. Can you tell me the zeros? Okay, so then you need to go and find the zeros on here. You need to tell me about the end behavior, what's going on. You need to tell me what kind of graph it is. My hint to you is that this is probably an x to the fourth graph because it hits here and turns, which means it hit twice. It hits here and turns, which means it hit twice. Okay. You need to look up exponent rules if you don't know them and complete. You need to go and you need to do the distributive property, which means you need to go distribute, 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 distribute. This becomes 2x cubed minus 3x squared plus x. And then there's a bunch of junk to add to that. Make sure you do it well. This half comes in and becomes 2x squared minus 3x plus 4. And then there's still a bunch of junk from here. You got to keep going. You have to finish. Don't forget to distribute those negatives. You have to keep going. You have to finish. They went and drew this out for you. They were like, a times a makes a squared. A times b makes ab, and it was negative. You keep going. You finish that out. You can do this one too. Notice that this is going to be a 2 by 3. Then it wants you to find the roots of this. This means you do the x in the box, or you do the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. You are doing everything all the way up to page 36. So let's go through that one more time. Starting on lesson 1. We don't need anything else on this page. We don't need anything else here. We did everything you need to do there. We are going to come back to this later, so leave this blank. We did everything you need there. We did everything you need there. Nothing there is needed. Nothing there is needed. Nothing there is needed. We did everything you need here except for number 16. So pause and do it if you haven't done it yet. Then restart. We don't need to do 20. Okay. I've already done everything you need on this page. You could use that piece or not. Okay, on this page you need to go through and complete. Either double distribute or the box, does not matter. Same thing here. Go all the way through. Okay, this page we have not done yet. Do not put an X through it. Just know that we have skipping that page for now. Everything you did here, I want you to tell me about the patterns. Restate. Everything you did here, I want you to go and restate. How are the zeros related? You should have done B. If you didn't, pause and do B now. Okay. Go ahead and cross that off. We already did that. Go mark the zeros. Go see what they have in common. How many zeros do they have? We touched on multiplicity. So anytime it turns, it means it really hit right here twice. We didn't do this yet, but we are going to do it later, so save it. Okay, we talked about multiplicity. We looked at this. You have to do some of those problems. You have to do these problems. If you don't know the rules, you need to look them up. You need to be able to distribute and combine. You need to be able to do a box. You need to be able to factor, whether it's using the x in the box or the quadratic formula. It is your choice. You have about 30 minutes left in class.